welcome back to AA's Team Series. I'm Aryan, and it's been a while, and I've missed you all. A lot has happened since my last video. I'm in high school now, and my studies have kept me pretty busy. Plus, I recently moved from BC to Ontario, which took some time to adjust. But now that I'm settled, I'm excited to dive back into making videos. Today, I'll be talking about electricity. This can be a 4-part series, so make sure to follow along. The first big question is, what is electricity? Electricity is the flow of electrons. It's the presence and flow of an electric charge going from one point to another. Types of charges: electrons, protons, and neutrons. Electrons are negative, protons are positive, and neutrons are neutral. For something to have a negative charge, it needs to have more electrons than protons. And for something to have a positive charge, it needs to have more protons than electrons. And for something to be neutral, like almost everything in our everyday world, like my table, my keyboard, they're all neutral, it needs to have the same amount of protons and electrons. And just so you guys know, these aren't just like 1 or 2 protons and 1 or 2 electrons. There are billions and billions of protons and billions of electrons. Law of electric charge. Like charges repel, unlike charges attracts, and charged objects attract neutral objects. So like charges, meaning a positive and a positive object, will repel each other, like this example right here. A negative and a negative object will also repel each other. But if it's a positive object and a negative object, these guys will attract each other. And the charged object, like a negative or a positive, will attract any neutral object. The strength of the electric attraction or repulsion is determined by the distance between the charged objects. So if they're super close together, the distance is super low, that means the force will be really great. And if the distance is really far apart, that means the force will be really little. The strength of the electric attraction or repulsion is determined by the amount of charge. Higher the charge, higher the force. Lower the charge, if there's very, very little charge, the force will also be very little. Law of conservation of energy. This is the most important thing in this video. You need to remember that energy can be created, energy can be destroyed. It can only change from one form to another. Keep in mind, protons can move because they are glued together in the nucleus. As you can see, this is the nucleus of an atom, and these protons are stuck together to these blue things, which are neutrons. And electrons can move around and can go from one object to another because they're just like they orbit around the nucleus. Electrical conductors. Conductors allow electrons to flow through them. Some good conductors are gold, copper, and steel. These, as you can see, they're all metals, and that's why most wires are made of copper on the inside. They allow electricity to flow through them super easily. And on the outside of the wire, so you don't get shocked, are insulators. Insulators hold on to the electrons very tightly. Most safety equipment is made out of insulators like rubbers and plastics. So on the outside of the wire is an insulator like rubber so you don't shock yourself, and to make sure that the electric charge doesn't travel through and shock you. Circuits. There are mainly 2 types of circuits, a series circuit and a parallel circuit. In a series circuit, the flow of electrons, it means they can only flow in one path. Electrons always start on the negative side of the battery, flow to the positive side. So in this scenario, as you can see in this series circuit, the orange is the wire, and these little black and yellow things are the load. It can be a light, it can be a motor, but we'll take these as a light. So the electrons will leave the negative side, go through here, and complete the circuit, and get recharged back in the positive side of the battery. And in a parallel circuit, the flow of electrons can follow more than one path. So when the electrons reach a branch, like here, they can separate. So they can either go here or here, and same thing here. But let's say that in this series circuit, this bulb stops working and it destroys the circuit. The circuit isn't complete anymore. It means when the electrons reach this point, they can't get to the other side and complete the circuit. So that means if this is turned off, the rest will be turned off too. But in a parallel circuit, if this bulb is turned off, they have an alternative path. So if this wire is just completely gone, they can still get through here and here and here and get back to the positive side, which means that the circuit is complete and these bulbs will still turn on. That'll be it for today. Thank you for watching. If you enjoyed this video, please drop a like. This will be a 4-part series, so make sure to subscribe and follow along. And again, thank you for watching.